All right, let's get you pumped up before you take this test, all righty? So make sure you're on the ready to go on page. What page is this? 121. 121, it looks like. Okay, ready? And again, a reminder that every time you are analyzing things here, I want you to be able to look at things, whether you have a table, whether you have a graph, whether you have an equation, and start thinking about, all right, what do I know? Can I get a picture in your head? What's happening with this relationship, this relation between X and Y, your two variables? So let's get cracking. This first one, here's a table. They give you the equation. They give you some input values. And here you're just plugging them in and letting it rip here. So I always like to do 0 first. -1, I believe, gives you -1. 1 gives you 5. 2 gives you 6, 8. 3 gives you 11. Okay. Next one, find the slope and the y-intercept just looking at this line in the graph. Now, my picture's kind of fuzzy, so in your book, I'm trusting that that y-intercept is 1. So the y-intercept is at 1. I usually like to write it out as an ordered pair. 0, 1. Slope, let's see here. It looks like there's another point on the line. Does this look like another one, I think? And there. So it's going upward. Your slope is positive. Count the rise over the run, the change in the y value over the change in the x. Up 3 over 1, up 3 over 1, up 3 over 1. Slope is 3. If you want to write it as an improper fraction, go ahead. Either way is cool with me. All right, next one, graph. Graph this using the slope and the y-intercept. So -3 is your y-intercept. Boom, boom, boom. Put a dot. My slope is positive 2, so it's positive. So it means it's going upward. A 2 is fairly steep because you're climbing 2 and going to the right 1. Rise 2 over 1. Rise 2 to the right 1. Up 2 to the right 1. Go ahead and build some to the left. I guess we can only fit 1 in on this particular grid. And then let's just hope you can draw straighter than I can with this thing. All right. Put arrows on the end, just so you notice how they do that up there too. All right. Okay, that's all we had to do there. Done. 4. Does this table represent a proportional or a non-proportional relationship? And it says it's linear, although I never trust them. I like to check myself and see, but here's what I see. My X inputs are 1, 2, 3, 4, 5. The Y values are 4, 8, 12, 16, 20. Now, if we had patience and a lot of graph paper, we could start graphing these points and take a look at them. Going up to 20 is kind of a stinky deal. Plus, if I just graph, I'm going by hand and there's really no guarantee. I don't see an input value of 0, so I don't know if 0 gives me 0 to tell if it's going through the origin. So then you have to resort to something else. All right. If it is proportional, you'll have a k value. A k is that constant of proportionality. What that means is there's some value here that you multiply by x, okay? Whatever your input is, you always multiply by this value, and that gives you or generates your y value. And it's the same for every single input for x. So I'm asking you, 1 times this k value is 4. 2 times this same k value gives you 8. 3 gives you 12. 4 gives you 16. 5 gives you 20. This one does exist. Your constant is 4 every single time. This one you can just see with your good old eyeballs. However, if they were yucky numbers that it wouldn't be as apparent, then I want you to take those values in the table, make this relationship to figure out what would be the rate at any given point each time. 4 over 1, 8 over 2, 12 over 3, 16 over 4. You get the same value. There you go. All right. Does the graph and exercise... Oh, so I guess I didn't even answer this. Yes, it's proportional. Sorry. All right, number 5. Does the graph in exercise 2 up here Is that proportional or non-proportional? Ah, that one is non-proportional. Why? Doesn't go through the origin. It doesn't ask for an explanation here, but if it did, that's what you would say. How about in 3? This guy? Oh, totally not proportional. Same reason again. It's not going through the origin. Proportional. That's a nice thing about the graph. It's so easy to tell when you have the picture. 7, wow, this is really the entire module all in one question, all right? So it's a little more meaty and there's a lot more to it. How can you identify a linear, non-proportional relationship? That's a lot of words. From a table, a graph, and an equation. All right, I'm going to take these out of order just because, frankly, table is the most wordy explanation. So let's start with the easy one, graph. How can you tell if it's non-proportional? If it's not proportional, it's not going through the origin, okay? Or you could say it has a different y-intercept. So here, if we wanted to write it in a kind of a negative way, you'd say it doesn't pass through the origin. And negative not meaning bad, but that I'm emphasizing a not in there. It doesn't pass through 0, 0. If you wanted to word it in a positive way, you would say it has a y-intercept that's not equal to 0, okay? Or that is any number except 0. An equation. This one, if you have the equation, it's pretty easy to tell if it is in this format, okay? And here again, what you're really focusing in on is that value that tells us what the y-intercept is, okay? So if the equation is in the form y equals slope times x plus y-intercept, mx plus b, the value of b, which is the intercept, is not 0. There you go. Now we get the UFTA one, all right? Did you ever think there was such a description as the UFTA one? Here comes the table. Now, I didn't like the way that the authors answered this question, only because they didn't get into the fact about making sure it's a line. Now, I know here, how can you identify a linear non-proportional? So maybe they're assuming you've already determined it's linear. Do you remember how we did that the other day looking at the examples? To determine if it's linear, you need to find the slope between every interval or every set of points. And if you can verify that it has the same exact slope between these two ordered pairs, these ordered pairs, these ordered pairs, then it's a line. And then how do you determine that it is non-proportional? Well, if you have a table, an x value of 0, I guess I don't need a comma there, gives a y value that is not 0. See how we're focusing tremendously on the y-intercept. I get this a little higher again. That is not 0. Okay. Now, that's kind of as far as the authors went with this explanation for table. However, oftentimes when you're checking, they don't put 0 in there. So it's not as obvious. You have to take it one step further. Now this one here in number 1, you figured out that at 0, you get a value of 2. Ding, 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 there's your y-intercept. See, it doesn't go through the origin. But down here on something like this one in number 4, You don't have a value of 0. How do you know? How do you know? You don't know unless you come up with the equation. This one would have y equals 4x as the equation. There's nothing else here. It's like plus 0. Wham! There's your intercept. So on this one, I would go one step further, and I would say this. You've looked and you notice if you have an x value of 0, you get a y value that's not 0. If you don't see a 0 in there, then what I would do is build your line. So if 0, and I'm writing it in words so you don't mistake it for an O. If 0 isn't in the table, calculate the slope. Choose one of the points. And then go ahead and graph or build your line. When you build your line, you'll be able to tell if it's going to work to pass exactly through the origin. If it doesn't, then you're good. Graph the line to find the y-intercept. There you go. Now that was super wordy, but I like to be way more specific, and the book was just not doing it for me here. To find the y-intercept. Beautiful. That's a great question. That question is like the entire test right there in one big old blob. Cool. All right, let's go to the next page and check these guys quickly now so I stop talking at you and let you take the test. The table below represents which equation? Which one is this? Well, there are a couple ways you can tackle this one, okay? Because I don't have the equation, you could start to graph it and then see what it looks like and see if you can determine the slope and the y-intercept. You could find the slope between each of these, okay? Let's see, if I'm going from a -10 up to a -6, my change in my y value is +4, and the change in the x value going from -1 to 0 is a +1. Is that the same here? Up 4 over 1. Up 4 more over 1. So my slope is 4. And if I do that, there's only one of them that works. Psst, an even faster way is to go right here. Whoa, that's a gift. That's your y-intercept. There's only one of these answer choices written in slope-intercept format that has a -6 as the answer. Great. What is the graph, or the graph of which equation is shown below? Okay, so the first thing you need to do is you should just look at this line and say, Shazam, it's a negative slope because it's going down. Goodbye, C and D. What's your y-intercept? +3. Ha, that leaves one choice left. I like to always double check. Down 2 to the right 1. Down 2 to the right. That's a slope of -2. Yeah. Okay. Number 3. The table below represents a linear relationship. So what it's telling you is that, yes, sirree, every time I calculate slope between each of these sets of points, I get the same value. From 4 to 7, I went up 3. And I went change in x value over 1. Up 3 over 1. Up 3 over 1. So there's my slope. Okay. It's asking for the y-intercept. Yeah. Well, you can't find the y-intercept unless you have the equation or you draw the picture. So I'm going to go up here and steal this graph, okay? The 0.24, and I'll tell you what, I'm going to change color just so I don't mess anything up. The 0.24 is right here, 24. And I have a slope that's 3, and it's positive, so I'm going really up 3 over 1, up 3 over 1. The problem is I'm going to fall off the graph if I go up 3 over 1, and I'm moving away from the y-axis. Well, that's no help. So let's build my line the other way by going down 3 to the left 1. Oh, that's cool. down 3 to the left one. Bam, 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 it's right there. What's the y-intercept? -2. Sweet. That's all they're asking for. But if they asked you for the equation, let's just be an overachiever. 3x minus 2. You can check them. See if they work. Plug in a 2. Do you get 4? Plug in 3. 9 minus 2 is 7. Plug in 4. 12 minus 2 is 10. There you go. All right. Which equation represents a non-proportional relationship? That means no origin. Well, this has a y-intercept of 0. That's going through the origin. This doesn't even have a y-intercept written, which implies it's 0. This one has a y-intercept of 5, and that has 0 again. So I guess it's C. All right, what's the missing value? I can tell you it is proportional. If it's proportional, it's going through 0. If it's proportional, there's a value k called the constant of proportionality. That's the multiplier. You're taking x times this multiplier k, and that's what gives you your y value. Okay, and it's the same every time. So 4 times what gives you 6? 10 times what gives you 15? If you can't see it in your eyes, take the y value divided by the x value, and that's the number. 6 divided by 4 or 15 divided by 10 is the magic 1.5 in this case. So what's 1.5 times 12? 18. What's this in scientific notation? What? I thought that was back in Unit 1. It was, and you shall never forget it. Here we go. Okay. The decimal point in scientific notation has to be behind the first significant digit. In other words, right behind the 5. Maybe, maybe, no, no. All right, so how many places did we have to go? Start here. 1, 2, 3, 4, 5, 6. It's A. Last one. Here we go. This is linear. Yep. Is it proportional or non-proportional? This is just a tell me answer. No reason. Necessary. What is the slope? Well, it's negative. I can tell you that. Start counting. Let's see here. Looks like there, there, there. All right. It looks like I go down 2 over 1. The y-intercept, boom, boom, boom. -3. What's the equation of the line? Slope times x, y-intercept. Whew. All right, are you ready? Are you pumped up? You ready to take this test and you are just all over non-proportional things and slope-intercept form? Go get them. May the force be with you.